specific stuff that we're working towards, and the proof of concept that we're working on towards that. And the second part is more for future work that we're looking into, and we haven't yet gone further than identifying some promising areas of research. And I'd like to share those with you that have to do with some of the uses of tagging in a more personal or a home space. And I'll talk about it in a workspace as well, so we'll get to that. So those are the two main components I want to talk about. Just a brief introduction, though, to the Human Communication Technology Lab at MAGIC. So this is where the work that I'm talking about is centered, is in these two places. So HCT Labs started in '98, and it looks at human experience and design techniques for looking at the creation of different types of experiential phenomena with respect to technology, but not necessarily only with technology. And then there's MAGIC, which started quite a bit before that, which is the Media Graphics Interdisciplinary Center. Many of you know that already, but its focus is on media technologies, more so now than on graphics, but graphics has been traditionally its other strength. And it has four areas of research: industrial linkages, developing local industrial bases on technology, media, and graphics, and facilitating that from the academic perspective, cultural influences of technology and media and graphics, and educational component as well. So those are the kind of super fast things, because I only have 30 minutes. But I did want to mention that just as an emotional thing. So some of the research directions that are going on, there is work in new interface design. So if you go to the website, you can get activities there in different ways. The cultural elements are still form a significant component of where we believe we can find either driving technology or technology driving those cultural expressions. So that's important. And then various modeling tools and graphic infrastructure, which I know sounds always very boring, but in fact that's what makes it happen. So we spend a lot of time thinking about different types of infrastructure, laying down guidelines and working towards specifications that will lay the foundation for some of the future application areas. So that's the brief introduction. So I'll go into two components. One is this thing called My View, which is a project that we work with our industry sponsors, Fels, University Labs, and our government sponsors, NSERC, through a CR&D matching fund. And the motivation does come from the Winter Olympics, because Bell is a sponsor of one of the sponsors, and their objective is to deliver some sort of personalized Olympic content over the web and through their wireless looking to promote in BC, so they're looking for ways to exploit that to promote. So that's how they came to me with. So the plan was to develop a multi-camera, multi-sensor data capturing system into a database. So taking various data, media data, video, audio, tracking information, that's all essentially tagged media data that appears into a media server, and that you provide client interfaces to that allow you to browse through video space in a context-sensitive way. So there's various object tracking or recognition with the sensors, and then a browser interface to allow you to navigate through the tagged media space. So we have chosen to focus on ice hockey for various reasons. One being that it's one of the few team sports. Think about the Winter Olympics. There's not a lot of team sport activity. So it provides a very rich space with people interacting. That you can have tagging being have a lot of interesting application of this, but this is just, we had to pick one. So the structure is one of these obligatory block diagrams, but the idea is to have a bunch of sensor data with some processing going on at the source. So on-camera processing or per-camera processing to deal with the complexity and the real-time nature of that data to automatically extract various types of meta tags. And there's also a thing we call an interpretation engine that runs not necessarily in real time, that's continually interpreting the data, adding new metadata to that video. So this can occur over hours, days, weeks, years. But that data for the Olympics is going to be around a long time. So that's the sort of data going in side of things. And then there's the client side, which as envisioned here is separated from the tagging, but it doesn't have to be. I'll talk about sort of the extensions of that when we get to the end here, but in the formulation for the Olympics, this client is purely browsing through this video and audio media space using the different types of tags that have been associated through this process. So I'm going to focus on this, show you what some of the things we've done here, a little bit on what we've done here, and not focus at all on that part there. So three main components: the browsing environment, the media capture plus the meta tagging, and the database access and logging. As I say, I won't talk about the last one. So the browsing environment sits down here. Whoops. And this has been work with Eric, who's here, and Justine, who was a student before, and Trisha Fang, who's a co-op student with us right now. And Justine Chen, or Jing Chen, is visiting scientist from China, working together on some of these, finding this problem a little bit better. So the objective for the browsing environment is to work in three different spaces: mobile viewing, Fels and Vatico, they look to deliver these content to the cell phones. So how can you browse the context-aware Olympic hockey activities from a cell phone? So that was one of the things we want to do. The desktop is still important, and the public display is also where the kiosks and that sort of thing. You want to be browsing through this large database captured and tagged hockey media. So the main idea is that you have these multimedia objects that have context-aware controls. So whenever you're looking at a video, say, there are a certain number of context-aware controls. So most video is fast forward, skip forward, skip backwards, play, pause. Those are the normal controls that whenever you see video, you kind of expect them to be there. So with these objects, you have another set of controls that will be part of the way of thinking of the data space to navigate and manipulate through it. So the context-oriented content can either be through explicit user control, so that you actually click on buttons or sliders to explicitly say. Implicit selection, that is, one thing goes to the next implicitly, that the connections are already there. Or a third-party director, that would be, watching hockey on TV, for example. There really is a third-party director deciding what's next, what you're going to see next. So all of these are important in determining what you're going to see next. These objects are self-contained, and so they can be embedded inside of other objects, text objects or web pages or something like that. There has been related work on this kind of approach. So in INRIA, they had the Opera project, which I was looking at. It's a little confusing, but ultimately it was integrated into SMILE as a mechanism for synchronizing all the content in when you're doing the offering and showing it in, I think only Real Player actually right now can play the So it's, anyway, it's very related to some of the work that the work at INRIA was doing. So what does it look like? So what does one of these browser things look like? So we're in the design stages. This is nowhere, this is the research project. And just to give you an idea of where we're going with it and what it looks like. So, so imagine that's a hockey player there. So this is just some video we took in the lab. And the database has for every single person where they are, who they are, what they are doing to some extent, with some probability or some likelihood of that accuracy of that data. So it may not be 100%. You may know only that it's player number 5 with a likelihood of 90%, and it's player number 6 with a likelihood of some other thing. Likewise, you may only know a position within a certain probability, and so forth. That's what's sitting on the server, and then you're going to go and watch that thing. So some of the things you might want to do is watch. You may just want to watch the game, but you may want to watch it from a particular perspective. So let's say it's the Czech team playing the Canadian team. You may want to watch it from a Czech perspective, which is different than the Canadian, say, what a Canadian perspective is. The emphasis on which players and types of shots, that kind of thing, would be different, and then it'll stream based on selecting, using the tags to select the appropriate videos, appropriate players, and the camera angles that would be appropriate for that perspective, as an example. Further, if you may be watching it and you might not have enough, you might not have, you may want to see a particular player. Maybe that's your daughter playing in the team Czech or something or other, and so you might want to see that player all the time. And now the camera angles, as the game's going on, will follow that player. It knows where it is, and that can occur in real time. After the game, still have all this data, and it's even potentially more meta tags that have been added to it. It's also where you could have users, third-party people adding more information to this database. And now you can browse, say you want to have a summary video, and you only have 5 minutes. You're more interested in shots than you are in passing plays or something like that. And that can refocus the kind of data that's going to come. Yeah?
Quick question. I think I missed something. How do the tags get there in the first place? Are they machine generated or user generated? Or
so they can be both. The emphasis on the research side of it is to actually automatically generate as much as we can. So some of that automatic generation will come from play-by-play, which is kind of in the middle of manual tag information. But there's nothing to prevent this architecture from, over the years, more and more meta information being used, included by hand, manually added, and or other automatic techniques. But the research that we're working on the back end, which I'll talk about just after this, is how could you get some of this tags automatically, and with a given probability. So we don't just want the tag, we also want the tag plus how confident you are in that tag, because there is uncertainty. And we want to be able to exploit that uncertainty, or actually just accept the uncertainty and use that in defining what the video that people will watch is. So for example, if I know that if I have a tag that says there's so-and-so there, but it's only a 50% likelihood, then when versus another part of the video where a player is identified at 100%, at the 50% one, maybe I better take a long view, like a far shot, because I don't know if that's the person there. And if I want that person in the video, if I just take a far away shot, then they're in there somewhere, and the person watching will know who it is. And then when I get to the spot where I know for sure they're in there, then I'll zoom, because I know that's not for sure.
Would you throw it out to the masses, so won't somebody say, oh, number 5, that's Joe Bloggs, or that's...
Absolutely, that'll get tagged later. And then the next time the algorithm's trying to do that, then they know with a greater probability. So again, though, you might want to still have the degree of certainty on it. because actually it kind of relates a little bit to the issues that were coming up before, which is just because somebody says it's something, that doesn't mean it is. So associating not just the tag, but a likelihood of that tag provides a different mechanism in terms of how you might use that data later on. Yeah?
Just on that point, you're talking about shooting in a very controlled environment, so couldn't you take that control one step further and put an RFID tag on every hockey player and you know 100% who they all were?
Absolutely. There's nothing in this, when I guess I did not emphasize it enough, but these are all,
okay, there we go.
all these possibilities.
Right.
There's nothing in here that's, this is just a rich tag media space that we're getting tags from all sorts of sources, and there's no reason it couldn't be user-generated tags. So that's getting accumulated here, and then how do we use that data? That's what I'm just focusing on that with respect to how you might browse tag video. Well, think of it as tag media space, but
yeah,
let's talk about video. How you might actually use that. And so these are some of the types of functions that you can imagine, including, now we have many cameras around there, so you can change the angle, pan and zoom. Those would be typical sort of things, fast forward, or step back, pause play. For a given sequence, those all make sense. But where it gets interesting is where, and we're still working on the naming for some of these things, is when you want to go into the content. So normally when you say skip forward, there's some content that you're skipping forward to. But if you're thinking, well, you know, what is the content that's coming up? Well, in a summary video, say it's a shot followed by a goal, another shot, maybe a passing play, another thing, you might want to change that based on how much time you have or what your interests are, or, you know, given what you saw here, you don't want to see the goal next. Maybe you want to see something, you know, what was happening at, you know, the other end of the rink or something. So you can then use this browsing control to change essentially the next set of sequences. So it's really just hyper video, really what it is. Though it's more than hyper video because you have a sense of the content, and then you can adjust based on those content tags to change the linear or non-linear sequence of video on the fly. Likewise, we are tagging the player, so if you click on a player, you can bring up information about the player, or you can say, hey, that player, track that player. So now all the camera angles will make sure that that player is seen as best as it can, assuming you're always in this. So this browser kind of idea, this media object, has associated mechanisms to move within the video, and then to develop a means of moving, of sequencing based on the media tags that have been placed in the database. So if you imagine like a YouTube, imagine taking YouTube where all YouTube videos had these kind of browsing things, and all the tags in there allowed you, and these mechanisms allow you to quickly browse through the tags to change the sequencing. So if you want to jump to something that's related, and it's something in the scene, these tools would be part of that video. So then you can navigate through that whole video space, if you like. So it was interesting with Phil, you were, is he gone now? Oh,
No, it's still here.
Oh, there you go. What you were saying, that you're sitting back there before. What you're saying that they're just starting to add the ability of Facebook with video and tagging of video. Well, now how do you actually browse through those things? It's going to be very complicated, and that's what this is kind of starting to look at that in more detail. So that's the direction we're going with that. Did have a video, but I'm not going to have time for that. So the second part that I'll talk about is the tracking side of things, which is where some of the technology that we're building is. So for that, we're using multiple cameras and tracking tags. At the moment, there's no reason we couldn't use RFID, sonic, ultrasonics, or other mechanisms, say in the ice, because it is a controlled environment. But we do have a thing called the local positioning system, which is an active tag-based tracking system that that uses infrared lights. We have a method that Hal here has implemented using a linear programming-based approach and histogram identification. A bit of action there. We are also looking, and it's planning to support on-demand viewpoints, so they can move the viewpoint within the scene. The expectation is to have a certain amount of activity recognition, so working with Jim Little and David Lowe, thinking about different types of activities within the game scenario that are going to be recognized, and we do expect to have other sensors involved. And those are the mechanisms we're going to be using to tag all that video, plus, I mean, the text, the play-by-plays. People can add tags to that content. That's another direction we can do that. To make this all happen for the video, especially the video source, we're developing this image processing pipeline to support the ability to add processing with each camera. Because once you have 100 or 1,000 cameras, it's really difficult to have them go to a single server or even a small set of computers. They really do need some embedded processing. And how do you write applications, image processing applications in a large scale? That hasn't really been created yet, so that's part of this project, is to create the infrastructure necessary to do that. Yeah?
Are you talking about a live video environment?
It's a live video environment. So there's two components. There's the real-time processing, so that during the event, there is tagging going on, and you'll be able to use those tags to do certain things, like follow a certain player. Make sure that the scene you see has that player on it. And that can be done in real time. But certain components are going to be done offline, like video summary. So given all these tags, plus a little more image processing time, sensor processing time, like combining different sensor information, we can get much better reliability on the tags, and that would lead to other types of browsing, such as video summaries or profile-specific summaries. So if you have certain things that you are interested in, it can generate summaries based on that, and then you can dynamically change it as you're watching the video summary. If you think, hey, that's really interesting, I want to see more of that, or hey, could you play it from a different perspective? That can all be done through the browser environment.
How do you give multiple users control of one camera? Like when you talk about the
There's like hundreds of cameras. The plan is to have lots of cameras, hundreds to thousands cameras, so that at any moment in time, just about every angle is covered at different zoom. So one of those cameras will be of interest. So it's not that any particular person. So if out of an ensemble of say 1,000 people, maybe 200 of the camera angles are being viewed simultaneously.
Wow.
Right?
But they're given control to can write or zoom in or zoom out. So what if there's two users on one point of view, one
I
point of
see.
view,
I see what you're asking.
and the control should suggest that you're able to control the.
Right. The camera's not actually moving. It's just what you see. So for a given image, if I wanted to zoom in, let's say I have an HD feed, I can zoom in on with that little screen. I can actually zoom in quite a bit digitally. The camera doesn't actually zoom. I'm just zooming in on the digital image and pan around it. But I can't go pan past it. If I want to pan past, then I'll switch to the next camera. And pan out now. Because cameras are fixed. They're not moving like a broadcast camera. So the broadcast camera feed is also part of the database, but then you don't have control over how it's zooming. But within what you see, you can zoom in, and you can zoom out to a certain level of that image.
Another camera source in this, of course, is the crowd. And like Roland here with his, everybody capturing that. Bell is deeply interested in feeding in over wireless cameras into their control rooms to actually capture crowd, capturing events and moving that in. So that's a different form of citizen journalism for sports.
Yeah, absolutely. So that's kind of how we can imagine making this all happen. So that's where that project is going. Or spending more time.
Could I
on
tag
that.
my camera as being the Robert Luongo camera, and I'm going to follow Robert throughout the game?
Yeah, that's one way to do it. With enough fixed cameras, there'll be enough for the game, but then for the individual perspectives, that can be added in as well. Problem is we don't know the position of your camera, but we can still process your images based on what all the other cameras are seeing, plus we know where the players are. We could probably figure out where you're sitting in the crowd and what your, how much depth of field and all the other things of your camera, and then tag all that. And if people, when they zoom in or they jump to a different video, the algorithm picks, hey, this is the best shot of that angle given what the person wants to see. So it'll start showing yours.
Remember that the game is actually the smallest part of why you pay $80 to see a hockey game. It's what's happening in the crowd around which gives that context. And so cameras which are watching the crowd, cameras in the crowd, cameras which are capturing that experience of the crowd with the game are as important as the game itself.
And the challenge is the scaling of all this stuff. Let's say you have, when I tell people, imagine 1,000 cameras, how are you ever going to get 1,000 cameras? I mean, that's expensive. Well, first of all, 1,000 cameras is about $10,000 of low quality cameras. Will cost you $10,000 to $20,000. It's not that expensive to have that many cameras. Plus, all the cell phones in there, they all have cameras. 1,000 cameras is quite easy to get. How do you process 1,000 cameras worth of data? That's hard. Computing has not scaled as fast as camera technology. So that's a big issue. And that's what this infrastructure to process the video that I was talking about, that's one of the things we're working on as part of this project. So there's the client interface, there's the mechanisms for doing the image processing itself, and then that whole querying monitor system to deliver the video and deliver the content. So that took much longer.
Wow, because I love hockey. This would be awesome.
So
1/10 of this
actually
working.
It's meant for the Olympics, but the original vision for this is not for the Olympics. It's really for your average event, where in your high school gym or in some concert hall or something like that, where there's lots of cameras around, and there's no broadcaster. At the Olympics, there's going to be tons of cameras and broadcasting going on, and but there isn't in your local gym. But you might want to watch your kid on TV, or your family wants to watch it, and this way it's all tagged. You can actually watch from your, watch Billy on the, skating around or whatever. This infrastructure would have support those kind of activities, and integrated with personal video as well, without too much difficulty. So anyway, that's the one project. The second project, which is where we're hoping to go, that relates to some of the tagging activities that we've been talking about, is part of what we call the At Home 2010 project, which is looking at smart homes and homes of the future, and where our interest is in the information management structures that may be useful to allow people to coordinate and organize all this information that, David, that you were talking about. Yes, there's all this information. How do you do something with it? How do you keep it organized? So the idea is to reorganize services to fit specifically identified digital lifestyles. So that's the main thesis of this whole project, is these digital lifestyle identifying those, and that's how we're going to reorganize the information system and the information, so that we separate the information that you're generating from the applications and the context that it was built, so that you can create your own context. And then your own context is where the meaning is, and then the support for those contexts is where all the value added is going to be. So I'll make that more tangible in just a moment, but in the end, we'll have new mental models and metaphors that will support your information management of your home space, of your home, and all home meaning all the information associated with your personal life space. That's your health records, your financial records, your photos, your media, your personal relationships, all these sort of things, which are accumulating already. That information is there. It's just not organized at the moment. So I'm running out of time, unfortunately, because of the last part of it. But the idea will be looking at how there's a difference between space and place. So space is your information space, and place is your physical location and physical world. The idea that this data is accumulating over time, that organizing and searching are main activities. So the tagging is allowing you to take advantage of your associated your cognitive abilities for association, and that's where how main memory works. Sharing as a critical component of your personal space, and device and connectivity codependence. So often people talk about device independence, that I shouldn't care what the device is, but I argue that in fact there is a codependency here, that on the devices themselves are a big part of your lifestyle, as is the connectivity of those devices. And so there's a codependence there in terms of your digital lifestyle, and you can design around that. And branding is another element that will become more critical, and tagging has a lot to do with that, because that supports the ability of these digital lifestyles, and therefore you can now have brands of digital lifestyles, and that's what you associate with, and that's what you develop around your space, your information space, your sharing, your devices, all involve a certain level of branding, and that's where some value added can be. So I'm not going to talk too much about space and place because I don't have time, but the main notion is that there's four places that you do activities in, and likewise there's 4 information spaces that are along the same lines of where you get data, where you get information, where applications occur, and that these things intersect. Typically in the physical world they don't intersect too much, but in the information world they intersect a lot. And a lot of this work that I'm talking about has already been done for the workplace to some extent. So, for example, if you think about your workspace, the desktop metaphor is a way of organizing all sorts of different artifacts that you have. So your file folder system, the desktop itself, control panels, a binder metaphor, various applications that are on there, and the documents on there. That's a metaphor space. And tagging is used. So if you have a Word document, it's a document that has Microsoft Word as a tag. It's got metadata so that it knows what that's all about. And that you can use, of course, for your own memory. You can search on that, on the types, all that kind of, that exists. And it makes so that when you see the icon, it shows it as a Microsoft Word document. And it's a nice visual reminder of that. I argue that the problem is that it's bound the application to the document itself. And so if you want a different look, because let's say that document has something to do with, I don't know, your trip to Australia, and it has something to do with Microsoft Word, and it has something to do with whatever, there's no way to change that representation because it's bound application document. So what it sounds from a tagging perspective,